Okay. So here, a few things I want to cover. We'll cover some of these things, discuss winding overload, EMI and EMC problems, in order fault, cogging torque, torque ripple, control diagnosis, etc. So when you have a winding overload, some of the symptoms you can have is it doesn't start, slow speed increase, humming, smoke, smell. So winding can any kind of winding, even if one turn has a damage in the motor, you can have pretty bizarre behavior in the motor. So all of these are you may see. Sometimes you say, well, maybe my controller is not working properly. Maybe there's something wrong in my controller, but sometimes it is the winding that is causing the issue, that you have something wrong with the winding. And winding behavior is never consistent. When you have winding issue, the motor behavior is not really consistent, right? You can't say, well, it doesn't start because it's a winding issue. It may be that it is actually having a very slow speed increase, which is because the winding is damaged in the motor. Okay, you can have a humming, which also can be related to you have internal short in the winding, so as a result, there is a short circuit in the winding, which is causing the noise humming. So the cabling between drivers and motors and long cables, obviously these can cause an issue in terms of when you have a very powerful drive. Let's say you are dealing with a few hundred kilowatts of power, and you have to now the distance between the load and your inverter is 25, 50, 100 feet, whatever it is. So now you have got these switching voltages being transmitted through these long cables. And that long cable is going to cause EMI issues, which can also cause control issues, because all of a sudden that noise is being coupled back to your controls. So it's very important to understand that anytime you have exposed cables and you have a switching voltages or currents being transmitted, you can have EMI issues around that area or around the controls. So obviously, when you're running it from the line, you can have the power line filter, the common mode choke. To the load, sometimes you can use essentially filtering here as well. But normally you do not use this kind of filtering for permanent magnet motors. Okay, you can have an LC filter here to ease the harmonics from the utility here. So there are some things you do in terms of easing your noise issues. Now, in case of you also have to think about that there's the bearing currents which flow through the ground when you have got switching. Okay, there's a coupling between your windings and your bearings, eventually your rotor and the bearings eventually. These coupling capacitors can cause current flow through your bearings, which can cause issues with your bearing as well. So that's something to keep in mind, that how the bearings can be electrically energized through your motor frame. Okay. And then in terms of inverter, well, I guess we're going to go into cogging torque solutions. Normally cogging torque is an issue where the motor does not spin smoothly. Although your controls are perfect, your motor doesn't spin smoothly because of the too much discontinuity between the rotor and the stator. So there are few techniques you can do in the controls. This is more of an issue, for example, in a BLDC motor where you have a trapezoidal drive. So if you have a trapezoidal drive, then you have more of an issue in terms of having cog torque.